Number 19 out of your textbook gives us the function f of x we're going to use the expression 3 minus x whenever x is less than 2, and we're going to use the expression x over 2 plus 1 whenever x is greater than 2. So when I go to graph this, it's not really too hard to graph. All right. So what I want to do is we're interested in at the point 2, and so I'm going to show you how to do this on a calculator. But it's a piecewise function, and so the piecewise functions are a little confusing. So let me pull up my calculator to show you guys what I'm talking about. How you can use your calculator, but you also got to use your head a little bit and kind of think it through. But basically, we're going to use two different graphs, but only portions of the graphs, and we got to kind of sketch them by hand to get a handle of things. So what I'm going to do then is I'm going to graph both these equations, but I'm going to do them one at a time. So I'm going to say 3 minus x. Oops, I did two x's. 3 minus x. Now, if I zoom in a little bit, let me just adjust the window. I'm going to go from 0, right? We're looking at, well, I guess we could go a little bit past that. We're going to go from x, the minimum x value from -1 to 2. Now the reason I'm choosing 2 is that we're saying x is less than 2. So I'm going to go a little bit to the left of that. Now truthfully, this is y equals mx plus b. This is a line that has a slope of -1 that has a y-intercept of +3, right? If I flip-flop the negative x and the 3 around, I can pretty much graph that in my head. The reason I'm only going for the x max of 2 is I want to see where this thing ends at. Now for my y-min, since I know it's going to kind of live up here in the first quadrant, my y-min can be like -1. I don't need to go down too far. And I know that my y-intercept is 3, so my y-max doesn't have to be 10, it could be 5. I want to zoom in and see what this thing looks like, okay? So let's graph it and see. So there it is. So if I hit trace, what I want to look at is 2 is not defined, right, because I don't have an equal sign here, but when x equals 2, what is my y value? 1. So what I'm going to have to do in order to graph this thing, I'm going to have to come up, so this is 1, 2, 3, and then over here I've got 1, 2, 3. 1, 2, 3. And so my graph has a slope of -1, and it is open at 2, 1. So I have an open circle here. X can be anything below -2, so my graph is going to kind of look like this. Okay? That's the first part. That's this part here. The reason I have the open circle is because I don't have an equal sign in my inequality symbol. If it was less than or equal to, I would have a closed circle right here. Now I need to look at the second equation. So I'm just going to purposefully get rid of this equation and put in the second one. Now, before I graph it, what's the slope of this equation? If I think in terms of y equals mx plus b. 1/2. What's the y-intercept? 1. So I already kind of know what this is going to look like. But let's graph it anyways. But when I graph it, I'm going to say x divided by 2 plus 1. Now when I go to my window, I want my x-min in this scenario to be 2. And I want my x-max to be like, I don't know, 4. And we'll leave y-min and y-max the same because I suspect they'll be very close or similar to. And then I'm going to graph it. So now when I hit trace, what I want to look for is when x equals 2. Again, there's no equal sign, right? There's no equal sign. So this is going to have an open circle. So where would it have the open circle at? 2, 2. So I'm going to use a different color. This is the second part of my piecewise function, and I have an open circle at 2, 2.
Wait, sorry, why is the circle open?
No equal sign. We're not including x equals 2. Now, what's the slope of this thing?
Half.
I'm going to go up 1 over 2. Up 1 over 2. So if I go up 1, I have to go over 2, and that's kind of going to give me an idea of what the graph would look like. Now, if that was the case, I should have the point 3, 4, right? So if I plug in 3, well, it won't be quite 4. If I go up 1 over 2, it's 3, 5, I think, isn't it? Or 2.5? What am I thinking of? No. I'm going to go over 4, so it'd be 4, 3. I'm sorry, I got it backwards, okay? Does that make sense?
Yeah.
All right, so that's the first part. I got to graph it and look at it. So now that I've done the graph, now I can actually answer the question. So the questions that they ask for problem number 19 is find the points of discontinuity. Are they removable or not? Now, I could have answered this by looking at just the equation itself. Where would my discontinuity occur?
2.
Because 2 is not defined in the domain. Another problem would be is the fact that that's the point where we might have a jump discontinuity. In this particular case, we do.
What does that mean?
The jump discontinuity means that I literally have to jump from here to finish drawing my graph. So now here's the question that I have for you guys. We know that so that's part A. Discontinuous, I know you guys can't see that at all. Discontinuous at x equals 2.
Is it x or y?
X. This is my x. So, since it's discontinuous, is it removable? Well, a removable discontinuity is where you can plug the holes.
No.
If I plug this hole, is the curve continuous? No. If I were to plug both holes, is the curve continuous? No, it's still a jump discontinuity. So I can't mathematically plug both holes, because if I do, then it's no longer a function, right? That would fail the vertical line test. But I went the extra mile to show you guys that clearly that is non-removable, right? So we're going to say non-removable. Okay? So that was part B. Are these removable or not removable? And give your reason why. So what would be our reason why?
It's a jump continuity.
Well, we could say that, but we could also say that the limit of f of x as x approaches 2 from the positive side does not equal the limit. So this is the more formal definition. What you said is absolutely correct, but it's not formal. The limit from the right-hand side is different than the limit from the left-hand side. That's why we have a jump discontinuity, because as I approach from this side, my limit is 2. As I approach from this side, my limit is 1, right? So this is the limit of f of x as x approaches 2 from the negative infinity side. Well, what's my corresponding y value? 1. Over here, the limit of f of x as x approaches 2 from positive infinity, because this is the positive infinity side, is equal to 2. And so because they don't equal each other, it's not a removable discontinuity. Does that make sense? Okay.